These are your 1-2 notes on order of operations. Pretty much reviewed today, so I'm going to try to go pretty quick. You can always pause and rewind and rewatch if you need to. We are going to use the order of operations to evaluate. So we're actually going to get a numerical answer at the end of all these operations. Some of them involve variables, so just replace the variable with a given value and evaluate after that. So it's important to understand evaluate. In your directions for algebra and geometry and all your math beyond, they're going to ask you to evaluate, and it just basically is fancy, just give me the answer. So it's a word that means find the value of an expression. Order of operations is a universal system to do that, to evaluate expressions in a specific order. We use it worldwide. Okay? If we didn't have this order of operations, maybe people in Germany would subtract before they multiply. Well, that makes a big difference. Maybe if you divide before you add, makes a big difference in your answer. So we needed a universal order in which we do our operations, and that's where order of operations comes from. So you guys have probably all heard of PEMDAS. Okay, I like to break it up though, and just kind of go through each of these PEMDAS. Notice in my chart, the M and D for multiplication and division are on the same little table because I want you to understand that multiplication doesn't necessarily always come first before division. And same thing with addition and subtraction, they're on the same level. So for the first one, parentheses, but parentheses, the P stands for parentheses, but it actually really means grouping symbols. So it could be parentheses, it could be brackets, it could be braces. So when it talks about the grouping symbols, it is basically telling you that if I have a number on the outside, but I have two numbers maybe on the inside, I want you to subtract those first. And maybe that wasn't addition, maybe it was like multiplication. So most of the time, the parentheses allow us to do to work outside of the order of operations. In this case, it's telling us before we do the multiplication, I want you to do the subtraction. That's usually when you see the parentheses. Okay, you can have nested parentheses, so you could have 3 plus 4 inside brackets times 2 inside parentheses squared, that sort of thing. So parentheses really means grouping symbols. Exponents for the E. So the exponents comes after the parentheses are done. So if I have 2 plus 3 squared, well, I have to do the parentheses first, then I square it before I do anything else on the outside. So if this said minus 7, I have to square it before I subtract it. M and D stand for multiplication or division, but this is done from left to right. So whichever one comes first, you do that first. Okay, so in 2 divided by 2 times 3, you are not going to multiply first. You're actually going to do 2 divided by 2, which gives you 1. 1 times 3 is 3. I also want to point out, do you notice how my answers keep getting smaller down the line? You work down the page. It'll turn into like an arrow or a triangle. It'll sort of funnel down to one number. Just like multiplication and division are on the same line, so are addition and subtraction. So you do addition and subtraction from left to right. So 1 plus 2 minus 3 plus 4, you're going to add the 1 and 2 first. Then you're going to subtract the 3 and 3, and then you're going to add the 4. Again, there's that funnel down effect of my answers. Each line got condensed because I was simplifying along the lines. Anytime you work with fraction expressions, where you have a bunch of stuff on top to simplify or evaluate, and on the bottom, you treat them as separate problems. So you follow PEMDAS through the numerator and then follow it through the denominator. And then common misconceptions are those multiplication and addition and subtraction. People think that we always multiply before we divide. That's false. It's left to right, and same thing with addition. So let's go ahead and evaluate. Now I'm going to really be picky here with your work. So when I'm walking around the class to check your work, I want to make sure that we have that funnel down effect. Every single line has one simplification and you write it down below, not across your page. That is inappropriate. It's just bad math logic. You work down the page. So using my PEMDAS, there are no parentheses, but there's an exponent. So I'm going to do this simplification first. So I'm going to write everything else the same way. The only thing that's going to change is what I have circled. You can do that if you want on your homework. You can circle what's going to change. One, or if you want to underline it, you could do that as well. One change per problem, per line. So no parentheses. All my exponents are gone. So please excuse my dear. I need to do multiplication and division from left to right. I have a division here, so I need to do that before I can do anything else. So I'm going to rewrite 16. Take away 8 divided by 4 is 2 plus 14. And then from here, I'm going to do the left to right addition and subtraction. So I'm going to subtract 2 from 16. I get 14 plus 14, and I end up with 28. Now, as we go through the year, these steps will get less and less, but because this is what we're concentrating on, I want to see all the work. All right, the next problem here, okay, parentheses first. So I'm going to take care of these grouping symbols. So 12 divided by 6 plus 5 times 4. 10 minus 6 is 4. Then I'm going to do, there are no exponents, so multiplication and division from left to right. Now technically, we could do both multiplications and divisions. I would allow you to do 12 divided by 6, which is 2, plus 5 times 4, which is 20. Because they are unrelated steps, I'm okay with you combining those and not having to show those separately. If you want to show them separately, that's fine. And then finally, our answer would be 22. And number 3, because I said to treat numerators and denominators separately as separate problems, you can simplify the top, simplify the bottom separately, and then we can worry about it later. So you can actually do a simplification in the top and the bottom at the same time. So for this one, 2 cubed is going to become 8. And then I can just do the subtraction on the bottom. 15 minus 9 is 6. So the next step would just be taking 8, take away 5 is 3 sixths. And if I wanted to, I could simplify that into 1/2. Now notice I worked aside because I'm simplifying the answer. I knew that 3 and 6 both had a 3 that I could take out, so I can write that sideways. It was just a quick little simplification. You don't have to work down the page for those. Here, I've got 2 problems where we have values given to us in the directions. We're going to replace x with 4, y with 5, and z with 3. So all I ask here, when we do when we have to substitute, you do the substitution first, then you evaluate. So I'm going to rewrite the same expression just with the numbers replaced. So y is equal to 5, so I'm going to write that as 4 times 5 plus 7 times 3. Parentheses are a good way when you're substituting values to put them in there so you know that I replaced that value. And then it doesn't look like a 45 and a 73. It still shows the operation of multiplication. 4 times 5 is 20. I can also do 7 times 3, which is 21, because they're separate from each other. And then 20 plus 21 is 41. Over here, 2y squared, that's 2 times 5 squared minus 4. So before I do any of the math, I'm going to replace first. Exponent tells me I need to square the 5. That gives me 25. Rewrite everything else. 2 times 25 is 50. Take away 4 is 46. So get in the habit of working down your page and showing me all the wonderful math. The math there, whether you need it or not, I need it. Okay, the math is for me and not you. You're having a mathematical conversation on paper with me. So your lesson summary. I want you to go through the whole order of operations, show every step of the way for that particular expression. And then I want you to do the same thing here, but this one where you have to substitute the values.